the opening part is gone there, but in this lab, we're going to be tilting this and seeing whether things slide or tip. As I was just saying, the weight is not relevant in any of this. So what I want to have you guys do for me is we're going to empirically find out, and it is by testing, where these things begin to slide. So for this white block, how many degrees of slope do you think we're going to have before it starts to slide? Anybody want to gander a guess?
13.
You've already looked ahead?
45.
If you've looked ahead, don't answer. So
What's the
let's find
material?
out.
Is that HDPE?
This is high density polyethylene, yes.
Okay. I'd
Whoever
say
got that, that was good. This one is Delrin, or homopolymer acetyl is the common name for it. But Delrin is what most people call it. It is usually known for having a low coefficient of friction. This is a rubber block. I can't remember exactly what kind of rubber it is, but it's a rubber block. And this is HDPE, as somebody pointed out. Also pretty good. The other thing I'm going to point out here is that when we're doing this, we're always going to use the same surface. So the coefficient of friction is only good between two known surfaces. So this surface and the wood surface always have to be the same. If I go to this surface, it might be a different coefficient of friction. So I'm always going to have to use this surface. The reason for that is that I don't know if you can see that, probably better on this one. Here you can see some striations. This is from where it got cut by the saw. And depending on whether or not it's got a whole bunch of ribs, surface ripples in it, will change the coefficient of friction between the two surfaces. And so the coefficient of friction is highly dependent upon the two surface materials and the condition of those two surfaces. So when you go and look at coefficient of frictions, and they'll give them for all the different things, they usually mean that the surfaces are smooth, but it can change when the coefficient of friction will change as the surface roughness changes. All right, well, let's find out here. Put this over here. And I did this earlier, and I've written them into the lab, but I just wanted to kind of go through it with you guys. So here we're up at 5, 8, 9, 10, 11, 12, 13. This is longer or greater than it was when it was earlier. So here I've got, that was 17 degrees. Now, when I did it earlier, it was 13 degrees. Maybe it was on a different piece of wood, or different section of wood before it started to slide. But anyways, we're going to go with 13, but that'll explain the results later on for the other part. So that was 17. Anybody want to guess on this one without looking at the future?
10.
Less. 7.
Okay.
9.
Is it heavier than the other thing?
So this is Delrin, and this has got a pretty nice smooth surface here. Let's do that. So now we're at 9, 10, 11.
Ah, dang it.
12, 13. That's about 14 and a half. I think I have 14 in the lab. Anyway. How about this one? Anybody want to get it? This is a rubber block.
45.
30.
30.
Yeah, this is it's as smooth as I could get it. Yeah, it's pretty grabby. I'm going to say it's pretty high. The other thing you'll notice is that it's not quite perpendicular. This stuff is incredibly hard to cut square. What happens is the material, as you're cutting it, kind of moves. And then when it's done cutting, it moves back to some other cut. So it kind of ends up with these funny little angles. But anyways, let's put it on there and find out. 30, 35, 40, 45.
Yeah.
Just, if you see it, it's just creeping. I mean, it's moving, but barely. Um, so I think I had that. If we look at the next page, I think I had that as 53 degrees. So, so use the numbers 13, 14, and 53 degrees for that angle. So, all right, I'm going to share my screen and we'll move on to the actual assignment here. So this kind of goes through what I just discussed already, but we have two major parts. So the first thing we're going to do is we just tested um, for the static coefficient of friction by just tilting the object and seeing when it slides. So we should be able to solve for the static co-friction mu s from that. What I'm going to show you here is fairly critical. So normally we would draw it like this. We would have our reference x and y perpendicular to the Earth's gravity, which would be W. But you'll notice that the surface is tilted and N and F, S are then rotated by whatever theta is. In this case, it's 10 degrees. I'm going to strongly urge you, and if you don't, I think you'll find this to be a difficult problem, to reorient your coordinate system so that X is along the surface of that wood plane where the friction is taking place, and Y is perpendicular to that surface. And then break W into components, Wx and Wy, based on whatever theta is. So if you use it this way, you'll find that you'll be able to do things much more easily. So now, our force couples, just as a reminder, our force couples are going to be Wx and Fs are going to be a force couple, and they're going to be creating a negative moment, and Wx or Wy and the normal force are going to be creating a positive moment. So those are going to be the two forces that are odds at each other at tipping. But so for turning the coefficient of friction, again, I've got these blocks here and I've got the weights. You should not need the weight. You should solve this problem and the W's ought to drop out. Again, if you use it like this, you'll find that that's the case. Let me go. All right. Well, I'm going to continue on, and I'll go back to this. What I wanted to say about Wx and Wy, in case you're wondering, Wx should be W times the sine of theta, and Wy ought to be W times the cosine of theta. I'll write that down in a little bit, but that's an important piece of information in case you're struggling with how to get that component. Hopefully you're not. But that's sort of it. So I wrote down the angles here that you can work this out. So in essence, what you want to do is do equilibrium equations for this diagram up here on the right and solve for mu s, the coefficient of friction. I also might add that I don't expect you to do the steps in this lab. That should relieve some of you, make some happy. No steps, just solve it. But please be clear in what you're doing. All right, so the next question is, do these things slide or tip? Clearly, they slide in the orientation that I just showed. The question is do they tip? And so I've given the dimension of those. I'm going to go back to the other screen. Stop sharing, and we'll try and tip them. So we're going to put it in this orientation, sideways on the thing here. And so again, I'm going to have people vote. Do you think it's going to tip first or slide first?
It's got a tip.
Going to tip.
Tip.
Anybody contrary to that? No, this is just guessing, so there's no wrong answers. All right, let's find out. So again, I chose the same surface. So I wanted to make the same surface. And we talked about how the fact that even though this doesn't entirely fit on this wood, we talked about how the surface area is, how much of it is there is not in the important aspect. So let's this up. We're at 13. So that tipped at about 13.5 degrees. All right, how about this guy? We're going to take the black Delrin block and we're going to put it this way. Is it going to slide or tip first? Any guesses?
Slide.
Okay.
Yeah, it's gonna
Slide. I mean,
slide.
it's not. That's not a fair. It's not different proportions.
That's the whole idea.
What do you mean?
So the whole idea is that it's dependent upon the proportions, right?
And the mute and the coefficient.
And the coefficient of friction. So
Changing multiple variables at once.
we'll get to this in a minute. This is why this lab is exciting. So let's just see. We're just doing the experiment first. So 14. So that started to slide at 15.5. That's a little above our coefficient of friction that we had before of 14 degrees. All right. How about this one? This rubber block. I'm going to put it this way. Actually, we'll put it this way. Is it going to tip or slide?
Tip.
Yeah.
Tip.
Yep.
Tipsy.
So we had 53 degrees is when it slid before, right? So it tipped at about 31, 32. So what I want you guys to do is to solve
37.
for the angle that it tips at, given the coefficient of friction that you solve for in the first part, knowing the dimensions of the block. Yeah, put a cow on there. That's pretty good, Vaughn. I probably have a little plastic animal somewhere, or maybe even a Lego figure I could put on there. I haven't got a real cow. So these are the dimensions of your block. So again, we'll go back to, this sort of, where's that diagram? Oh, it's on the previous page.
Do we have to do it in 3D?
No, this is a two-dimensional problem. So we'll be using, forces like this. We'll be looking at A/2 and X. And again, as David pointed out earlier in the lab, the way to figure out whether it tips over or not is to place n at the corner, so X is equal to A/2. That's the secret. Yes, and that's really it. What you're trying to do is use the point at which theta begins to slide in this aspect ratio, as Jason pointed out, when we know that it's going to slide, and find out what is the coefficient of friction. So basically use your equations to solve for the coefficient of friction. And then we're going to turn it sideways into this orientation and determine when it ought to be tipping. What angle would it tip? And then we're going to compare the two angles, and that'll tell us whether it should have tipped first or slid first. Now, you already sort of know the answer because we experimentally did it, but I want you to show to me mathematically what is supposed to happen. As you noted already, the differences between what I did last night and what is here this morning in terms of these angles is a little off. The white plastic block actually had a much greater, I think it was like 15 or something. But leave it at 13 for now. Go ahead and solve things that way. Let me go back to the whiteboard real quick. This forward. It's an exaggerated angle, but there it is. This is theta. We've got our block. So all right, this is the essence of what we're working on today. So in the first one, you're just going to solve for the coefficient of friction, US, which is, as you recall, so you're solving for this because you know theta. And the other one, what you want to do in the second part is solve for the moment at this corner and solve for when to solve for what theta will be at a point where it starts to tip, i.e. where the moment in a negative fashion is greater than the moment in the negative fashion. So you set the two equal, the two moments equal to each other, and that will be the point at which things start to tip. All right, I'm going to send you guys into breakout rooms. And I think last time we discovered that some people didn't have the ability to pick their own breakout room. So I'll start you off just random breakout rooms. And if you have requests to move one way or the other, that's just fine.
Can I ask a question?
Absolutely. I was going to say, does anybody have any questions? Because now's the moment.
Okay, it doesn't really have anything to do with this specific assignment, but do we have to turn it in on engineering paper? Because I usually do my work on scratch paper, then transfer my work to engineering paper.
I prefer it's on engineering paper. Yes, that's my preference.
Okay.
Any other questions? Like I said, I was kind of surprised that the second part, you also do not need to know the weight. I don't know why I was surprised, but I was. And when you solve for it, you'll find that weight plays absolutely no role in this whatsoever. As Jason pointed out, it's all about the aspect ratio of the sides. All right, here you go.
He's not here.
Lol.
Oh, hi,
Yeah.
Laura.
Okay, so I went through and the first white block I missed it, but the downslide,
Come again?
first block slide or tip, the white block.
Oh, you're all done.
Yeah, I missed.
So the first block should slide given the
Yeah.
numbers I've given,
Okay.
even though in our experimental it tipped. I think my experiment of determining where it slid was on a slightly different patch of wood. It really, these surfaces need to be homogeneous, i.e. uniform throughout, and they're not. But
Yeah.
the calculations say it should slide
Slide.
first rather than.
Okay, so yeah, so for my mu s, I was left with the tangent of the angle gives you your coefficient of static friction.
The tangent, you said tangent of the angle?
Yeah.
That's it.
And then
So you
for,
got to plug in the angles.
yeah, and then for part 2, I got that delta x, or the x over the y gives you your coefficient of static friction.
We're trying to determine whether it tips at a certain angle or not. So what you should be getting are certain angles.
Yeah,
So there
so
should be 3 angles and whatever they are.
because I did the moment about A. So the moment about A would be negative the weight of X over, I used, since it's in the middle, I used delta Y over 2.
When you guys say delta Y, are you saying the Y component?
Yeah, the Y component over 2.
Okay. I actually have the answer for all that is that theta is equal to the inverse tangent of the base over, the height. Yeah,
I think
base
it's
over the height.
base over height. X component over Y component of center of gravity. Yeah, that's what I got too. So
Yep.
I had a quick question, Rob. So for part 2, we don't need to, because nothing has changed from part 1 and the I mean, even though the orientation has
Slide.
changed, we know when it's going to slide still.
Yes.
Okay, cool. I just wanted to make
Yeah,
sure we didn't need to like redo that, because we never took into account the orientation, and because we empirically derived the angle. So
Yeah, and we knew it was going to slide the first time, and we empirically, yes.
yeah,
So, correct.
okay, cool. Thank you.
Yeah, like I said, this lab is either super fast or, some people just thrash around forever.
Yeah,
You guys are in the fast category.
thanks, Rob.
You need you guys to go back to your rooms, or can you do that yourselves? Or do you have more questions, Laura?
Yeah, well, I just wanted to make sure. So for the part two, because you got something different than I got.
I have what did you get again?
So for part two, you're trying to find the coefficient of friction with these new conditions, right? Using the moment equation about A.
No, we've already established what the coefficient of friction is in the first part.
Yeah.
We're going to use that coefficient of friction throughout the problem. What we're trying to establish is at what angle does the block tip?
Okay, because I did it different. What I did is I just found the coefficient of static friction with these new conditions. And I know that if it's greater than the one I already calculated, then it will slide. But if it's less than, then it'll tip.
So the coefficient of friction should stay constant between two materials and two surfaces. So that's not really it should always end up being the same number, I guess. The question is that coefficient of friction? So, oh, I see what you did. You tried to solve for if it tipped, what would the coefficient of friction have to be?
Yes.
Huh. Well, that's okay. That works. That wasn't what I asked for.
Yeah.
I asked for what angle does it tip.
But
I guess let me look more closely. I think you may be right in the sense that I may ask whether does it just slip or tip. And if that's what I asked, then the way you did it is perfectly acceptable.
Okay. I still want to understand the other way. So let me, I'm going to spend a few moments just doing it the theta, like finding the angle, and just make sure I got the same thing.
Yeah. That's an unusual solution, Laura. It is, but it is correct. You are. I just wanted to let you know that you're correct.
Okay.
So,
and to do it, so then if I
a
find
little hand of mine here because I'm happy that you worked it out a different way.
Yeah.
You know, there's always more than one way to skin a cat,
Mhm.
unless you like cats.
Okay, so then if I wanted to find the angle, then I would have okay, let's see here. So I would find the moment about A, right? And the moment about A would,
Find the moment about the lower right-hand corner.
yeah, that's what in my diagram, that's what I had A as, so the lower right-hand corner.
Okay.
So if I did that, it would be negative the X component of the weight
Mhm.
half of the length of Y, right? Okay.
Right.
And then plus the Y component of the weight times half the length of the X.
Right.
Right?
Now, if you substitute in for the Y component of weight as W times cosine of theta,
Right.
and for the X component of weight, you substitute in the W sine theta, now you should be able to solve for theta.
Oh, okay, so I just substitute in those and then
Yeah.
just yeah, okay, I got it.
Yeah.
Okay, let me try it out, go back to my room, and then I'll try it out, and then if I have questions, I'll come back.
Okay, I'll be floating around them, so you can always send a whatever it is, the text thing.
Sounds good.
Not there. Hi, Laura.
Yeah.
Somebody said they created another log on for themselves and it's not there. Anyway,
What was that?
yeah, I'm not seeing it, Isaac.
It's called Daniel Shaw. Never mind. It's not called Mini Me anymore.
Okay. All right. So you want that in,
36.
that I can do.
Thank you so much.
All right, so when I did theta, I got the inverse tangent of x over y. But I think the other gentleman got y over x.
Correct. That should be, it should be over X over. So what I got was base, and I have base, which would be your X,
X,
H, which is Y. I have it as the arctangent of what you have is X over Y. Is that what you got?
Yeah.
That is correct.
Okay. And then, so I have,
Otherwise, the angle's too big.
yeah. Okay, yeah. So then, I think I got it then.
Hey guys, they must be done. This is going pretty quick. I guess it's a nice change of pace, huh?
Yeah, for sure. That you usually stay here a longer time.
Well, I suppose it's only fair.
Yeah. So then if my angle, the angle that I calculated then, conceptually speaking, it's the angle of where the block would slide. Or is
That
it-
angle that you just created would where it would tip.
Okay.
So then the question becomes, would it slide first or tip first? And so we have the angle at which it'll slide, and then we have the angle of which it would tip. And whichever of those two is smaller is what will happen first. So as you're slowly increasing the angle, if it comes to whichever angle it comes to first of either the tipping or the sliding angle, that's the activity that's going to happen.
Okay.
Does that make sense?
Yeah.
So
So,
whichever of those two is less.
okay. So this one will tip and the.
So for instance, the white block, according to our calculations, should slide first, but I think my initial coefficient of friction was too low. Somehow last night when I did the experiment, the coefficient of friction was lower.
Mhm.
Anyways,
'Cause
so
it's,
the first one should slide according to our calculations.
yeah.
They're very close.
Yeah, it's
They're
just
within a degree.
the second one should tip, or no, should slide first. And the
Yep.
last one should tip first. Okay.
Yep.
Okay.
So you've done it both ways now? That's great. That's fantastic, Laura.
All right. All right. Thanks, Rob.
Yeah.
I'll see you later.
Yeah, take care. Have a great weekend.
You too. Bye.
So I think I have the same question, but I didn't hear her question. But my question is, do we have to find whether the block is going to slide or tip? Or are we just using your data, like when you demonstrate us?
Mm-hmm. So we know when it slides because we know what angle it was, and we solved for the coefficient of friction using that angle. So we know when it slides, at what angle. The question is if we reorient the block in a different way, will it tip or slide first? So we know when it'll slide because nothing in those equations changed at all.
Mm-hmm.
So that question is, will it tip before it reaches that sliding angle? So we solve
Okay.
for the angle with which it'll tip, and
Mhm.
whichever of the two is less is what will happen first.
Okay. Awesome.
That makes sense?
Yeah.
Cool.
Thank you. I'm gonna join the breakout
Yeah.
room now.
Hey, Rob.
Hi, Maria.
I
Are you done?
I don't know. I don't know. I think I'm done, but I'm not sure. I wanted to ask you to make sure.
Okay.
So I found the tipping angles for the blocks using the moment equation
Uh-huh.
at the corner. And
Right.
now I'm just curious if I just compare those to the angle that the block slides at.
Yes. So we should have tipping and sliding angles, and whichever of the two is smaller is what will happen first. So for instance, in the white block, even though it tipped first in our experiment, according to our calculations, it should slide first.
Yeah.
They're very close to each other.
I was wondering, is that because, oh, that doesn't have to do, you were saying with the surface area. I was wondering if that was.
It has to do with, my guess is that when I did this experiment last night, and I did it several times to see if the sliding angle of 13 degrees was consistent, and it was. I think it was consistent where I was putting the block. I think I may have put it in a different location this morning, and so the
Okay.
angle was greater.
Okay, but what about how because when you did the sliding, you had the block set up like this versus when you did the tipping, you had it set up like this. Do you think that could have anything to do with it?
It won't change the calculations on when it'll slide first, but it will change the calculations on when it would tip first. I purposely chose the other orientation for examining the sliding because I knew it was going to slide before it tipped. It was such that, when you look at that equation, we end up with what theta equaling the arctangent of the base over the height. I knew that the base was big, so that we were going to have a much bigger angle.
Okay.
We could have done that calculation too, but it seemed pointless. That seemed like just more calculations for you guys.
Okay.
Does that help? That answer?
Yeah, so basically we just have to compare it to the angle of slide that you put in the lab.
Correct.
Okay. Okay. Sweet. Then I think I'm
So
done.
have you got answers for all three?
I have that the white block will tip at 14.25 degrees. The black plastic block will tip at 35.6 degrees.
Yep.
And the rubber block will tip at 34.8 degrees.
That's it. You nailed it.
Okay. Great. Cool. Thank you, Rob. I appreciate it.
All right. Have a great weekend if I don't see you again.
Okay. You too. Wait, Rob, can I ask you? I'm always curious about your work. Can I ask you what you're working on right now?
That's it.